In this video, we want to solve this question on regression analysis. It says a driver recorded the fuel consumed per kilometer traveled in 6 different routes as shown below. So here is the table. So the question now says determine the appropriate regression equation. The second one says predict the distance if the fuel consumption is 9 liters. Now we notice that the fuel consumption is x, so we put it, and the distance is y, so we put it. We put the table, serial number. So we have 5, 7, 3, 2, 8, and 6. And we have 7, 9, 6, 8, 12, and 12. So, because it is a regression equation, it is represented as y equal to a plus bx, which is the linear regression model, where you are plotting a graph of y against x, and a is the intercept, b is the slope. So we need to find the values of a and b. If we are estimating for a, we make a subject of the formula, it becomes y minus bx. If we are estimating for b, b becomes n summation xy minus summation x summation y all over n summation x squared minus summation x all squared. So we need to find b first, because in the formula for b we don't need a, but in the formula of a we need b. So find b first, and in the formula of b we have xy. So we found the table xy. We also have x squared, so we put the formula, the table x squared. So this times this gives you this times this gives you this times this gives you, so this times this gives you 35, this times this gives you 63, so this times this gives you this, and so on. For this x squared, so this one gives you 25, this one gives you 49, this one gives you 9, this one gives you 4, this one gives you 64 and 36. So we're going to summarize them. The n is the serial number, which is 1, 2, 3, 4, 5, and 6. So when we add this up, we get 31. When we add this up, we get 54. When we add this up, we get 300. Likewise, this will have 187. So n is already 6. So we say 6 times summation xy, which is 300, minus summation x, which is 31, times summation y, which is 54, all over n is also 6 times summation x squared, which is 187, minus summation x, which is 31, then squared. So here, this times this, we get 1800, minus this times this, we get 1674, over this times this, we get 1122, this squared, we get 961. So we have this minus this, we get 126, this minus this, we get 161, and the b becomes 0.782. So next is to find a. For us to find a, let's just use this space. For us to find a, we know that a is equal to y minus bx. So y, we have many y, so we pick the average, which is summation y over n minus b. For x, we have many x, so we pick the average, which is the mean, summation x over n. So a becomes, summation y is 54 over n is 6, minus the b we got is 0.782 times summation x is 31 over 6. So what we are going to do now is to divide. If we divide this, we're going to get 9 minus 0.782. If we divide this, we're going to get 5.167 approximately. So we multiply this. When we multiply this, we get 4.04. bring down 9 minus, so when we minus it, we got that the value of A becomes 4.96. So let's turn. So what this thing means is that y equal to A plus bx can be written as y equal to the value of A is 4.96 plus the value of B is 0.782, then x. This is the regression equation for it. The B part said we should find or predict the distance if the consumption is 9. So they're actually asking us to find the value of y when B is 9. Sorry, when x is 9. We're looking for x when x. We're looking for y when x is 9. So y equal to 4.96 plus 0.782. Instead of x now we put 9. So we have 4.96 plus 0.782 times 9. Okay, 4.96 plus we multiply this. If we multiply, we get 7.038 instead of rewriting this again. So when we now add, we get 11.998 kilometers. So the distance that it will travel can be predicted to be this.